Hello students, today we're going to look at some vector diagrams and get used to the proper way to label the sides of our vector diagram and the correct terminology that's going to be used when working with them. So let's start with question 1 on this assignment. Question 1, you have this diagram, and I see this 28 degrees right here at the top. All right, now what that means is if you see the angle, that tells me that if a person were walking, they started right here. All right, that's our start point. That's our origin. What this person would have done is they would have walked from that starting point towards the west. All right, so this right here would be one part, and this is called a vector component. All right, now a vector component, that's one part of the complete vector diagram. It's one piece of the puzzle. Now when that person walked to the west, they turned direction, and then they started to go south. Now this right here, this is again another vector component. You can think of it as it's part of the description of you trying to tell somebody how this person was moving. They went towards the west, and then they turned and they went towards the south. Now, if you were a bird that would be flying from that point of origin to where they stopped at, all right, what would be a straight line path? Well, we would do this dashed line right here. Now this dashed line, that's not the actual path that the person followed, right? We're just saying that if we were to go and draw a straight line from where we started to where we ended up at, that's what that particular dashed line would represent. Now the correct term for this is called a resultant. All right, now a resultant vector is simply the sum of the western direction and the southern direction. So we would describe this resultant vector, or in this case, since the person was walking, it'd be the person's displacement. Okay, so we could use either of those two terms to describe that purple dashed line or the black dashed line right there. All right, so a resultant vector, a displacement, will always have magnitude and direction. Part of that direction was to the west, and part of that direction was towards the south. So we have 10 meters, and then we would put in the direction of this. We would say 28 degrees, and it's not south and it's not west. It's south of west, because we would have to go towards the south, or I'm sorry, towards the south from the west or direction to get to that purple vector. So what you are going to do is I want you to go through and label up these vector components. All right, so if we use B here, we have our point of origin right up here, okay? And if we're going to label these vector components, if this is my angle, this is that 15 degrees up here. If this is an eyeball that's looking out and we're going to label up our vector components, which side is the opposite to where that angle actually is? Well, if we are looking out of that corner, all right, if this person is standing right here and they're looking out of that corner, which side is opposite of them? That's side B. This is the opposite side right here. So this would be the opposite side, and again, that is one of our vector components. The second side that we're going to label is the adjacent side. Adjacent means that we're right next door to it. So which of these would we consider to be the adjacent side? Well, that's going to be side A. This is the adjacent side right here, and again, that adjacent side is a vector component. It's one piece of the puzzle. We have one last side that we're going to label, and it's always the longest side. The last side that we label is always going to be the longest side, and it's always going to be the resultant. That side is going to be called the hypotenuse. So we're going to say hypot, and the hypotenuse is always, like I said, the resultant vector. What you're going to do now is you're going to go through these diagrams, and you're going to properly label which side is the opposite side, which side is the adjacent side, and which side is the hypotenuse. You have to be able to do that in order to solve vector problems correctly. If you are going to struggle with labeling the opposite side, the adjacent side, and the hypotenuse, you need to get some help right away. Now, if you're good with this, go ahead and get started. Stop the video, go to it. If you need a little more help, I'm going to show you a couple more, and then I'll turn you loose. So we have number 3 on the homework assignment. You have letter C right here. If we're going to label these sides, and I'm going to choose a different color so that way we can see it better. You have the angle is right here. Okay, so that's our point of origin. You're standing right here. Okay, which side, if you're looking out from that corner right there, which side would look like the opposite side? That would be this one right here. Which side would be the longest side? The longest one. Which one is the resultant vector? That's side C. So we would label this one the hypotenuse. And then that leaves the last side. The last side is the one that's right next door to it, the one that's adjacent to it. We're going to put adjacent right here. We'll do one last one. We have this angle right here. We have the 35 down at the bottom. The 35 down at the bottom, that is our point of origin. So if we're looking out from that point, side B would be the opposite side to where I'm standing. Side A would be the adjacent side. And then side C, the longest one, the resultant vector, is the hypotenuse. All right. The rest of these are up to you to complete. All we have to do is use that idea to answer them. If you have questions, make sure you ask.